Okay. All right, so this is a graphing calculator question. Get out your graphing calculators. You cannot do this question without a graphing calculator. As well as tonight's homework, you cannot do it without a graphing calculator. Y'all have a quiz on Thursday. It's a partner quiz, group quiz. You cannot do it without a graphing calculator. All right? My job is to get y'all feeling comfortable for that quiz on Thursday. So let's go ahead and read it. First of all, put these signs are messed up.
No.
Look at all these signs where they're messed up. You see? Okay. See all these they look like negatives. They're equals. Okay? Supposed to be all equals right here, 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 and here. Okay, so correct those, please.
Okay.
All right. Now, let's try to all move through this as quickly as possible. Try to get it done in 20 minutes. All right. So, from 0 to 6, a particle is moving along the x-axis. The particle's position, x of t, is not given. So we're given velocity, v of t equals 2 sine e to the t over 4 plus 1. The acceleration of the particle is given by a of t equals 1/2 e to the t over 4 times cosine e to the t over 4, and x of 0 equals 2. Is the speed of the particle increasing or decreasing at time equals 5.5? All right. What do I need to know for speed? Velocity. So let's all go about finding the velocity. Here is, you could just plug it in your calculator. All right. Right? We could just plug it in our calculator, so go ahead. Velocity, this function, and here's how I would write it right here. Just say, hey, I need to find v of 5.5, and just use your calculator. Okay? You don't have to show any work. Plug it in your calculator. Now, if you don't know how to plug in your calculator, watch it. All right, v of t is 2 sine e to the 5.5 divided by 4. Don't end the parentheses up top. Is everybody seeing what I'm doing? What can I not forget? Plus 1. So make sure you can plug that in your calculator correctly. Second natural law. So I'm going to write down over here, v of 5.5 equals negative 0.453. And since that's my answer, I can round to the third decimal place. I don't have to write 10 digits. Now, what does that mean?
Decrease.
My velocity is that doesn't mean anything about my speed is decreasing. That means my velocity, I'm moving this way.
In another direction.
I'm moving backwards. I'm moonwalking. Okay? Now, how do I know whether or not that speed is increasing or decreasing? What should tell me that? What happens when your velocity is increasing in your car? Speedometer is increasing. You're pressing the gas. You're accelerating. All right? If your speed is decreasing, you are hitting the brake. You are decelerating. So we also need to know the acceleration. So let's do the acceleration. Everybody with me on the calculator. Oh, I did X. Dang it. 5.5. Alright, let's see if we all get the same thing there. Alright, now start picturing this as a car. Alright, were we all clear? Now, what does this mean? This means we're going backwards, and we have a decelerating force. So if you're going forwards and you have a decelerating force, it would cause you to move. It's pushing you backwards. But if you're already going backwards and you have a decelerating force, what's that going to cause you to do? Go backwards faster. And since speed does not include positive or negative velocity, your speed is increasing. So you're in reverse, pressing the gas. Okay? So here's what you would write to JYA this. If I could find it. I lost it. Nope, here. No.
Bonus points.
Okay. So here's what I would write in this case. You have to use calculus. You have to state something about the velocity or something about the acceleration. Because the velocity is less than 0 and the acceleration is less than 0, the particle speed is increasing at t equals 5.5. That's what you would write down. And I encourage you to write that down as well today, because you're going to have to do it tonight. Okay? Velocity is less than 0. That means you're in reverse. Acceleration is less than 0. That means you're pressing the gas, but you're pressing the gas in a negative direction. Now, you okay?
Yeah, I'm good.
Wakey. Should I be playing some rage music for you during class? You wake up. Alright. So, because V of t is less than 0 and A of t is less than 0, the particle's speed is increasing. Alright, now next, find the average velocity. There is a tool that we took a test on this, I believe it was unit 11 or 12. We had the average value tool. And that's the average value tool. Everybody write it down. 1 over b minus a from a to b. Sorry, that's my penmanship. Lags in many areas. Okay? So everybody, let's take a look at this. 1 over b minus a, integral from a to b of v of t dt. Okay? Look at the v of t. That's an ugly, ugly formula. You can't integrate that. It's impossible. So we have to use our calculator. So everybody plug the v of t. Let's see, I've already got it into my y sub 2 from last period. Alright, go ahead. Yeah, you don't have to plug it into y sub 2 as long as you remember where you plug it into. It don't matter as long as you remember where. Now, do it. Integrate it. Use the average value tool. Read the problem. 0 to 6. Gives you your intervals. So when I'm done, I can quit. Math 9. Rock it out. 0 to 6.
dx, right?
Yeah, dx. Alright, we should already be inputting this into our calculator. 0 to 6. Vars. Remember, that's how I get my y sub 1 or 2. Vars over function. I need y sub 2. You need y sub 1. Dx. Should be getting that. Everybody double check, see if you get that. Do we all get it?
How do you do it the old-fashioned way?
Huh?
How do you do it? This calculator is different.
Funky? Let me show you on the big screen. See if you got math type. You don't have math type. Go to Miss Skogsberg, you'll get math type, and she knows how to input that. So you do math 9. Alright, you're going to do y sub 1. Is it y sub 1, Tommy? Yeah, okay. Tyler. Comma x, comma 0, oop, comma 0, comma 6. Just remember that sequence, okay, Tyler? Y sub 1, x, 0, 6. Oh, it's thinking. It's thinking. Way too long. It's still thinking. Alright, it's going to sleep. Oh my gosh.
It's taking a nap.
Yeah, it's done. I don't know what's happening.
It just broke it. It's divided by 4, so
Oh yeah, divided by 4.
that's why.
And you might not be in radians. Yeah, you are. Alright, let's try this again. Whoa.
That's wrong.
That's what I got.
Maybe it's 6, 0, 0.
Was it 2 sine x?
2 sine.
Did you get the +1?
No, it's at the bottom.
+1 right there. Right there.
2 sine e to the x over 4. Oh! Didn't end your parentheses. That's alright. That's why it was stinking thinking so much. Yeah, boom. There we go. Alright. So, let me show you this. This is wrong. Look. If you write this on the AP exam, you will be wrong. Let's look. Look right here. This next part, you can just write the answer for your calculator, but be careful how you write your answer. Because the answer is 11.696. But what am I forgetting here that's going to make this wrong? Thank you. Because this does not equal 11.696. It equals 11.696 divided by 6. Okay? So if I write it this way, I'm correct. And since this is not my answer, I must write how many digits? All of them. You must write all the digits. Then divide by 6, and boom diggity, you got your answer. Y'all write that down. You're going to have to do that tonight on your homework. All right. All right, we're going to go over one more thing. We're not going to do D, because D isn't, it is important, but C is like ultra important. Now, I've learned that I like to hear myself talk. But if y'all want to talk over me, please do. I actually like getting talked over. That knows I'm getting feedback. I don't want to hear myself talk all day. So, as we work through this problem, tell me what you think.
Wait, why is it U over T?
Oh, because it's velocity. Now, it doesn't have to be units over time, but they're picky. Like, if you given feet in seconds, they want you to write feet over seconds for the units. But a lot of times it'll say indicate units of measure. And it didn't. I just put U over T because I felt like it. All right. Ooh, total distance traveled. Multiply by 1/6 or just divide by 6. All right. Now, part D on the homework is hard. That's what I was telling last period. All right, so total distance traveled is graphical integration. Do you understand integration graphically?
Sure.
Total distance traveled. How do I get the distance function? I must integrate the velocity. But I usually think of integration of a function as area under the curve. I don't think of it as distance traveled. But here's what I want you to understand. Every little teeny little unit of area is a distance traveled.
Yes.
Okay? So, what type of area here? Positive. So we are traveling forward. What type of area here? Negative. So we are traveling backwards. So how do I counteract the negative area with the positive area? I minus it. Because I don't want it to be negative because I want the total distance. I could run around in circles, end up in the same spot. Now, how do I find this? I need to do second 0. Let's look at the graph. Everybody go to y equals, and I want you to do zoom trig 7. And this gives us a good picture of the graph.
Oh,
What happened?
I still haven't used that.
All right. So, where does the positive area become negative?
Right over there.
At the 0. So I need everybody to do second trace 0. Left bound means I take my spider and I move it to the left side of the 0. Zip. And I take my spider and move it to the right side of the 0. Zip. And then I attack the 0 with my spider. Right there. All right, 5.195523223. Okay? Now, do y'all want to write all 10 of those digits every time? No. So that's why the next step I do is to store. Store 5.1952223. And then I can write my integral like you see right here. Because of the Jordan rule, he said we needed to minus it to counteract the negative area to find the total distance traveled. Okay? I'll just go ahead and give you the solution. And okay. So if y'all want to play with that, play with the store, play with the intersect, and notice you're going to have to write it down on your paper and then store it in your calculator. You can't flip from the graph screen and it transfer the digits to the home screen. So does anybody need to see how to store? Because you're going to have to do it tonight on your homework. Storing. Let's store. 5.1955223. Store alpha A. That's how you do it. Everybody try that. And then you hit enter, and when you hit enter and it works, then you know you did it right. Okay? And then I have to do some math 9s. What's my first, look at my first integral from 0 to a. I don't want to write all 10 of those digits. That'll give me the positive area. From a to 6 gives me the negative area. Notice how I have to write 10 digits every time. Whoops. I have to write 10 digits every time. Okay? So play with that, see if you can get 12.134700039 and see if you can get negative 0.43849. All that. And then you minus them. Okay. That's about all the time that I want to take up. So after you're done playing with that, your homework is 2003 AB2. You should be doing roughly 10 of those derivatives a day. You can do them while you're in PE too, or while you're in English class. That doesn't really matter, right? I'm kidding.
Wait, what's that
Don't. 2003 AB2 and working on your derivative packet.
2003 AB2.
Now, go ahead and write down on it. Part D is hard. Okay? Part D is hard because we haven't really talked about it yet. It's just different. You can do it, it's just different. But A, B, and C, you should knock it out in 15 to 20 minutes. Like, really. Okay? So, you got your homework. You got your derivative packet. I'm willing to help you wherever you need to be helped. You got five or so minutes. Bless you. About 8 minutes, y'all. So try to get some done.